Okay, good afternoon, colleagues. Thank you for joining me for this uh, introductory course to databases. We are trying to continue from where we ended, but just before we move further, just want us to have a recap on what we looked at, particularly the major aspect we touched on last time. We did say that you cannot talk about the databases, anything to do with database, without talking about the data and information, and then talking about the knowledge. Okay, so these are the basic fundamentals that you need to understand before you delve into talking about databases. So we discussed data, we discussed information, we also discussed uh, knowledge. Okay, we also spoke about the knowledge generation, the process of how you generate knowledge. Of course, through that we have data involved, we have information involved, and once these are consolidated, you tend to get the knowledge. Okay, then we brought in the issue of the concept of database management system, which we did say that is just a platform actually that allows you to interact with the database. We said you cannot interact with the data or look at the data that is stored in the database without having the DBMS. Okay, so this one helps you to interact with the data in the database. Then there was also some data, a shared collection of interrelated data that is designed, okay, to meet the varied information need of an organization. Okay, so I said it's a shared collection of interrelated data or a collection of interrelated data designed to meet the varied information need of an organization. So database management system comes in to be described as a collection, okay, as a collection of um, programs to create and maintain database. Hello? Hello? Yes. Yeah. I was like, if you reached home, oh, how's your GP? Okay, so we're saying um, database management system, we talked about it as a collection of programs created to programs to create and maintain the database, and in that you have to define the database itself. Then you create what we call the constructs, and then you should be able to manipulate the data in the database. Okay, then we also looked at some of the advantages of database processing, okay, compared to flat files and so forth. Quite a number were looked at, and these were, we found this to be very common, and we also have some disadvantages of using databases, which we discussed again in our last meeting. Then we did indicate that the objective of management system approach is basically to ensure that we have what you call a self-describing aspect of data. Then there should be some form of data independence. Then the database should give you multiple view, as well as being able to be accessed by multiple users. Okay. Uh, went further to look at what is contained here. We did talk about the data, the concept of metadata, then access engines, then utilities, and so on. Then files and database management and databases. We discussed also what data about data is. Okay, where we said this is basically metadata. It just provide a description about the data in the database. And we did indicate that database access, for you to be able to access the database, you need an interface, and then this interface will give you access to the database. Okay, so this interface is basically a computer program which we are calling as the DBMS, that is there to help you look at the database. So today we're going to look at the history of database system. It is gratifying to know that we have what you call a file management system, which is one of the tradition and most hard form of the database management system. Or okay, now we moved from the file management system to what is known as the hierarchical model. This was actually propagated or uh, pioneered by the IBM in 1966, and from the hierarchical model, we had what we call the network model. This was pioneered by uh, a gentleman called Charles Bachman. Okay, when he came up with an integrated data store. Okay, that was in 1965. Okay, so this was an idea actually by an individual. Then from the network model, the relational model came into being, and this came in by a gentleman called Code, and this was in 1970. Now under the we have what you call the Boy's normal code or Boy's normal form and so forth. This is why it was originated from. So these are the four aspects of database management system that we are the history of database that we'll look at. There's one file management system, and then hierarchical model, the network model, as well as the relational model. You can wait for it. All right. So the file management system. So this one provided the facility to extract data and share files, okay, but did not implement any way to connect record in one file to those in another. Okay, so basically what we are saying is that under this concept, in this file management system, we only had the way to extract data and share files. This was the only possibility that was achievable in this kind of in this technology. Okay, this was the only possibility, only to extract data and share a file. Okay, but you could not record or reconnect or connect one record from one file to another. In short, we're saying the aspect of relationships were neither here nor there. So that aspect was not there. So the relationships under the file management system had to be implemented in an application um, code. Okay, so these were not there. Okay, so you look at this is the database system versus the file system. Okay, this is the file system where we are saying we have the first program, the second program, and the third program. Of course, each of these programs have what we call the metadata, okay, which is just the description of data itself, and then we have the data there. So now when it comes to the database itself, you find that these are combined. You could have different programs there, like program one, then here second, and then third. So these are combined. These are combined under one description. Okay, they are combined under one descriptions to basically help with the description of the data that is stored in the database. Okay, so this provides us with a difference between the file system as well as the database. Okay, under the file system, each of the program had its own description, meaning it was independent of the other. But when it comes to the database system, the programs here, they are independent, of course, but the description of all these programs is contained under one file. contained under one file. All right. Now, when you look at the structured databases, under this concept, the relationship were implemented by physical pointers, or what we are calling the sets. Okay, so the sets were used to implement relationships. Okay, and this allowed for records to be connected in different files. So you could connect one record from one file to the other. Okay, so the hierarchical structure aspect allowed us to have a record that is interconnected from one file to the other. Okay, so under hierarchical databases, okay, hierarchical databases allow only one parent set. You could only have one parent set. Okay, network allows several. Okay, in that case, what you are meaning is that we could have one file that contains everything. Okay, and these others can make use of it and access it through the parent file. So these permit efficient processing, but the set must be constructed on data entry and cannot be rearranged later. Okay, cannot be rearranged later. Okay, then when it comes to relational model, the relational model implement relationship with matched data value in a related files. Okay, so these matched data values are called the primary keys and foreign keys. So any attributes can be matched based on the keys provided. Any of the attributes can be matched based on the keys provided. So the connection is established at retrieval. So interconnection can be developed and as needed. Okay, that's um that's the relational model. It provides basically the aspect of relationship where um, one entity, or can say one file or one file can be linked to another. So they can be what we are calling interlinked between the files that contain certain information. So meaning you are not only restricted to a particular um, order, but you can easily use what we call the primary key as well as foreign keys to interconnect uh, your your files. Okay, this is an example. We had the section A, student, then instructor, then student, college, then instructor also correct. So each can have only one parent. Okay, this is just showing one parent as an hierarchy. Okay, where we have student as well as instructor, all have one parent. Okay, all of them can only have a single parent. Okay, the network section, each file can have several parents, both sections and the college are parent files. Okay. Um, okay, that's the network where each file can have several parents, and both sections, like in our case, sections and college are parent files. So meaning each child can have more than one parent in this hierarchy or in this particular model. Okay, so those are some of the examples: the relation, the section, section A instructor, section S student. Okay, so each of these have what we call the section key, student key. Okay, where there we have instructor key. Now on the student key as well as the instructor key. Okay, what's happening is that this is basically showing the relationship. Okay, so relational terminologies, these are the terminologies that are used when you are dealing with relationships in terms of um, databases. So you come across these terminologies quite often. You need to understand them. Okay, we have what we call the entity. Entity can be a person or a place or a thing or even an event about which we wish to keep data about. That is an entity. It could be a place, a person, or even an event of which or where we want to put our data from. Okay, then from there we have attributes. Okay, here you could see here. This is an attribute which is basically a property of an entity. Okay, an attribute is basically a property of an entity. It's part of an entity, so to say. And never get confused when you say attribute. When you say attribute, we are basically talking about an item in a particular table, such as a column name, a column right, and so on. Then from attributes, we have relationships. Relationships, which is an association among entities. In one database, you could have as many entities as possible, as many entities as possible. Now, entities must associate with each other. Okay, these entities must associate with each other. There must be that kind of relationship between these entities. Right, there must be that relationship between these entities. Okay, so this is about relational terminologies. First, you understand that you have entities. When you talk about an entity, this could be a person, a place, or a thing. In other words, we could say maybe you have a table, okay, a table of a person. For a person, in that table, you could have attributes such as the name, student name, then student number, year of study, and so on. Okay, so this could be regarded as attributes of that particular entity. But now what we are saying is that there must be some form of relationship with other entities. What are the distribution strategies for databases? Okay, how do you make your people in the organization access your database? How do you make your people in your organization access your database? This is what we are talking about. Okay. Okay. So one way is what we call centralized data and processing. Okay, here you make use of what is known as a dumb terminal, okay, with just screen scraping, okay, whereby you are saying you just have a terminal. Of course, this cannot do any processing, okay. So that is one way you could do, uh, uh, you could distribute, your database application, or how it can be accessed through what you call centralized data, and you have a particular processing that is done in a central location. Okay, it's done in a central location, but the um, but people can access the data from anywhere around there, but the processing is done centrally.